Alright, diesel engine mechanical service manual, diesel electric, General Electric. Alright, the fuel oil system. Description: the engine fuel system is contained with a fuel tank located below the locomotive platform. Fuel is drawn from the tank. Fuel tank by electric-driven fuel booster pump and is circulated through the system. See Figure 5.9. The fuel system consists of the following components listing according to fuel flow from the fuel tank through the line through the system: fuel tank, fuel heater, optional prime filter, fuel booster pump, relief valve, secondary filter, engine fuel header, injection equipment, and regulating valve, fuel drain headers, and single element fuel strainer. The suction side of the system is between the tank and the booster pump. The fuel is drawn through the fuel heater with the optional through the single element fuel strainer before reaching the pump. The pressure side of the system is between the booster pump and the pressure regulating valve, which is discharged excess fuel back into the tank. The fuel discharged by the booster pump flows in a large single element primary fuel filter relief valve that's connected with the pump discharge and protects the booster pump from the overloads caused by flow of the restriction by pressure side of the system. The three-element secondary fuel filter serve to more completely filter foreign particles from the fuel. Fuel is conducted with the secondary filter through a pipe and to the engaged fuel header. Alright, the individual flexible hose connected between the injection pump fitting inlet fittings make up the engine fuel header. The fuel header is first supply the fuels into the injection pump on the left bank and then crosses over near the turbocharger, supplies the injection pump on the right bank. Excess fuel returns to the fuel tank through the regulating valve. The regulating valve adjusts and maintain pressure for the engine fuel header. The two drain headers, one in each side of the engine fuel engine frame, collect the fuel leaking back from the injector's high pressure pumps directed back to the fuel tank. The locomotive is equipped with a single fuel supply tank centrally located between the platform. The tank is equipped with two fill openings, one on each side of the tank. The two fuel level sight glasses, one near each of the fill opening. With any standard equipment on the tank, the fuel level dial gauges may be applied with to the tank. Optional equipment that one sub located lengthwise bottom of the tank is equipped with both ends with the condensate, the drain valve, and a large drain opening with contains the plug. The two vent pipes vent the tank to atmosphere. Electric emergency fuel cutoff. The electrical operated with emergency fuel cutoff switch is arranged with three emergency trip switches, one located near each for the tank fill openings, one with the operator for the cab. Momentarily depressing any one of these push buttons will stop the fuel booster pump, thus stopping the flow of the fuel to the engine. At the same time, a signal with the engine governor stop of the engine. The system is restored with the normal operation by depressing a reset button in the operator's cabin. On starting the engine, the system will be reset automatically. Fuel servicing. Fuel oil specification. Fuel oil recommended for the engine must be distilled. The fuel should conform with the American Society Testing Materials Specification D975. Number 2D for extreme low temperature for the engine's high altitudes. Number 1D fuel with a minimum cetane value of the 45 may be used. Filling. Fuel filling may be done with either side of the locomotive by applying the fuel hose to the fill opening. The fill fittings may differ depending on the customer performance. Observe the upper side of the gauge periodically during the filling to determine whether the tank is full. The full supply may be determined at any time with observing the upper and lower side gauge of the fuel dial gauge if used for the indicating fuel level. Draining. The fuel tank should periodically drain with accumulated water condensate that may be accomplished by the temporary opening condensating drain valve at each end of the tank sump. This valve may be made with a straight-headed through screws. Thread screws which contain a drill passage which internal stop with the limit of the number of turns that they can be opened. If an excess amount of water is found within the fuel tank, check with the engine fuel filter system and the fuel supply should be made immediately. If the water is permitted to enter the fuel system, it can cause extensive damage to the system parts. Large quantities of fuel may be quickly drained from the tank. Removing the drain plug from each end of the tank sump, the sump end covers may be removed. Gaining access to the tank with internal cleaning becomes necessary. Fuel oil strainer filters. Description. Figure 5.1. The fuel injection equipment is protected with the foreign material by a fuel oil strainer, primary and secondary. Filter. The strainer is attached with a bracket mounted to the right side of the engine near the fuel booster pump. Primary and secondary filters are attached to the bracket mounted on the left side of the engine. Figure 55.1 shows 1. The air vent screw, 2. The cover nut, 3. The filter head, and 4. The shell assembly, 5. The center bolt, and 6. The filter element inside. Fuel straining assembly consists of the fabricated steel with the housing of a signal fine mesh mono wire screen element. The strainer is connected with the suction side of the booster pump, removes the relatively large particle with the foreign matter from the fuel before it reaches the sump. The primary fuel filter assembly consists of a large steel that can be which houses a single large filter element. See data section. See the primary filter and pipe connected with the booster pump, the fuel discharge opening. A secondary fuel filter assembly consists of the cast manifold, 3 filter shells. Each shell contains a filter element. The shells are arranged in a parallel flow. The assembly is pipe connected between the primary filter and the engine fuel header. Primary and secondary filters complete the fuel filtering process by removing small foreign particles in the fuel, protect the engine fuel injection equipment. Element cleaning and changing. A gradual drop of the fuel flow header pressure indicates that the fuel strain with the filters have become restricted should be either cleaned or replaced. Fuel strainer. Remove and clean the strainer element. Remove the drain plug with the strainer housing to drain the housing. Loosen the wing nuts on the strainer cover and remove the strainer element. 3. Remove the rubber grommet from the end of the strainer element. Flush the element with a clean solution, blue and dry with a clean air. The flow of the strainer housing with a clean fuel oil and blow dry with clean air. Inspect the rubber grommet and rubber O-ring with the housing under the strainer cover either with the item that's damaged. Install a new one. 6. Install the grommet and strainer element with replace the cleaned element. Replace the strainer plug fill in the strainer shell with a clean fuel oil. 8. Replace the strainer cover and tighten the cover with wing nuts evenly carefully. Your primary fuel filter. When conditions indicate the primary fuel filter should be replaced, drain the filter, remove the drain plug located at the bottom of the lower end of the filter housing. 2. Loosen the cover, clamping the bolt with slowly remove the cover to prevent the filter element. Hold down the spring from flying out. 3. Remove the filter element. 4. Thoroughly flush the filter housing with a clean fuel oil, blow dry, clean air. Inspect the rubber OA ring with the housing undercover. If damaged any of the way, replace the new O-ring. 5. Install the drain plug, insert the new filter element. 6. Replace the hold-down spring and cover. Tighten the cover bolt. Secondary fuel filter, see figure 5.1. When the secondary fuel filter element have to be replaced, proceed as follows. Open the drain cock, drain filter shells, loosen the cover nuts until 3. Lower the shells assembly. 3. Remove the discard unused filter elements. Flush with the clean oil. Blow out filter shells. Close the drain cocks. 4. Remove the protective wrapper from the filter elements. Install the elements and filter shell. Press the elements down firmly and fill the shells with clean fuel oil. 5. Use the new shell gaskets and play for the shells again for the filter heads. Engage the center bolts and tighten the nuts securely. 6. Restart the fuel booster pumps and loosen the air vent with a screw when the fuel leakage is free of the air bubble to close the vent screws. 7. Check the shell gaskets, vent screws, and drain cocks for leakage after a short period of fuel booster pump operation. Booster pump and motor. Description. The fuel booster pump is a gear type pump driven by the directly electric motor through the flexible coupling and maintains constant supply of fuel to each cylinder injection pump. The pump housing is constructed as part of the motor end. It eliminates the shaft alignment problems. The motor base is fastened with a supporting bracket with it bolted to the side of the engine frame of the left side of the locomotive. Pump rotation is indicated by an arrow of the pump housing with the direction rotation counterclockwise for when we're looking at the pump drive shaft end. Inspection and maintenance. When pump fails to work properly, external leakage appears with the check with the coupling parts, pump, housing, rotors, idle gear wear, and chip for the worn pump parts. Care must be taken when connecting pump piping with the pump pipe housing, the distorter of the misaligned pipes, and also applying pipe compound, applying the compound with the male fittings to prevent compound from entering the pump. The system of the pipe compounds contain the abrasive material will damage the pump parts if allowed to enter the system. Pump and motor. The 75-volt DC motor is compound with the wound in a totally enclosed armature shaft, rotates, seals, and ball bearings. The motor communicator brushes can be removed by removing the gasket covered over the bush brushing openings. The fuel pump motor assists with the regulating fuel header, but the pressure of the motor is constructed with a variable with the speed ranges from 1800 to 2200 RPMs when pumping against 40 psi to 0 psi respectively. No, do not run the pump without fuel longer than 2 minutes. Pump gear draw damage will result with lack of fuel, which lubricates the pump parts. Engine drain system. When the slight leak of the fuel for the injection pump and the injection nozzle, each of the pump cylinder is normal. The leakage fuel is required to lubricate the pump and the injection nozzle and must be drained with the fuel tank. The system passages which each of the cylinder assembly conducts the leakage of the fuel through the upper portion of the cylinder around the base of the injection pump and downward through the pump push rod cavity. Figure 5.2 shows the fuel pump, booster pump, the discharge pump, the fuel pump, the coupling, the inlet pipe, and the motor. The passages in each cylinder basically are aligned with the drill passage for the engine mainframe, with the fuel drain header pipe that is attached to each side of the engine mainframe, with the connector to each of these passages to collect drainage fuel. Each of the header pipe that's constructed with an open stand pipe at one end, with the other end with the connected with the return drain fuel to the fuel tank. The fuel drain system must remain free of obstruction to permit gravity flow of the fuel to the tank. The in system should be clogged and if the system should become clogged, fuel dilution of lubrication oil may occur. System priming. Normally, it's not necessary to prime the fuel system as regulating valve with the will vent of the system when the booster pump is started. However, the good practice when replacing the primary filter element to fill the filter shell with clean fuel before installing this will ensure the against the pump damage to the insufficient lubrication during initial startup, allowing quicker primer over the starting. Your relief valve. Description: see Figure 5.8. Relief valve A is located in the fuel system between the booster pump, discharge, and secondary filter. The valve protects the booster pump against the electrical overloading, protects the system against excessive pressure caused by clogged secondary filters or fuel flow stoppage in the pressure side of the system. Adjustment: remove the 1/2 inch pipe plug and install the calibrated 100 psi test gauge at the test point 1. 2. Cap off the header leave the 8R pump and start the booster pump to observe the test pressure gauge at the data correct value setting. To correct the value setting, remove the valve cap, loosen the adjusting lock nut, adjust the slotted screw to the desired pressure, to turn the screw in to raise the pressure, turn the screw out to lower the pressure, tighten the lock nut, replace the valve cap to check the gauge reading in the top of the booster pump. 6. Remove the test gauge and restore the piping of to normal. Regulating valve. See description figure in 5.9. The pressure regulating valve D monitor near the secondary fuel filter is located in the system between the fuel tank engine header the maintain fuel header pressure when pressure for the test point 2. The C data for the correct valve setting. When setting these fuel header pressures, the engine must be stopped. With the primary and secondary filters must be clean. The fuel system must be free of air bubbles. When the fuel header pressure drops slowly over the period of time, they usually condition the clogged fuel filters, or the incorrect setting of the pressure regulating valve of the filter element should be renewed first. Then, if necessary, to adjust the pressure regulating valve as follows. Adjustment: install 100 psi test gauge at test point 2. Note: be sure the fuel strainer elements when to be cleaned with the new elements have been installed with the primary and secondary filter. Start the fuel booster pump engine with the engine operating at the idle speed. Read the pressure indicating on the test gauge in the data section. Remove the valve cap, loosen the adjustment lockout nut, and adjust the slotted screw with the desired pressure. See the data valve setting to turn the screw in to raise the pressure, out to lower the pressure. Turn the adjusting lock nut, replace the valve cap to check the gauge reading. Stop the engine and booster pump. Remove the test gauge and replace the pipe plug, replaced with the pipe plug. Fuel injection equipment. Pump removal. See Figure 5.3. Remove the spring clip with adjustable link with the connection pump rack with the fuel control linkage. Wash the high pressure line with using the sift bristle brush and fuel oil before disconnecting. 3. Remove the high pressure fuel line between the pump and the injector. Cover the opening for the pump with the fitting of the threaded or plastic caps. Remove the fuel branch line between the fuel header line with the pump with the cover the header pump pipe connection. After the fuel has been drained with the header, apply the clean plug and an inlet connection of the pump. 5. Remove the mounting bolts into the base pump using special shaped wrenches. Lift up the pump and engine from the engine and cover the area with the pump where removed to prevent the foreign material from entering the engine. Left the spare pump is installed immediately. Alright, 1 is your high pressure line, 2 is your fuel injection pump, 3 is your compression release plug, 4 is your fuel header line, 5 is the fuel injection nozzle hold down clamp, 6 is the cylinder cover, and 7 is your pump rack linkage. 6. Remove the fuel inlet tee and apply the clean plug with the inlet in the connection. Installation. Caution. Before installing pump, the engine shortens the tappet rod length and remove the cover at the bottom of the cylinder. See Figure 5.4. Loosen the lock nut, tap the nut, using 2 open-ended wrenches. Turn the tappet adjusting nut and lock nut 4 or 5 turns clockwise, and excessive tappet rod travel the can damage the pump tappet rod assembly. Figure 5.4, fuel injection pump tappet rod adjustment, push rod tappet adjustment, then umbrella locking nut, and then fuel drain header of or speed oil supply line cover plate. Note: when installation pumps, be careful that no dirt and foreign material enter the fuel oil lines, connections, or engine. Keep the plugs or seats in place where the connections are to be made. Install the pump and cylinder. Secure the mounting bolts with the seat data for the bolt torque, and connect the fuel header with the high pressure fuel lines. Install the adjustable link between the pump rack and the fuel control link, and secure the link with the spring clipping. Pump timing adjustment. See figure 5 and 5.5 and 5.6. When timing the fuel injection pump, the following indication marks may be referred to as prescribed line for the pumping time window. Set marks on the timing ring with the bar bearing over the hub. The timing window over the covered with the plug is located on the lower outside of the pump housing. Each side of the window is described with the timing line. The plunger follower pump appears behind the timing window and it is upper end of the edge of the used to set the pump timing. The pump is properly timed. The upper edge of the plunger follower will exactly line up with the scribe timing marks at the edge of the pumping window. The engine timing ring is located with the outer face of the bearing over the hub at the free end of the engine. The ring contains the 4 pump set marks at each mark contains 2 numbers. Numbers identify the N8 pairs the opposite cylinder, for example, the 1827. Our figure 5.5 shows 1, the injection plug, injection pump, 2, the plug clamp bar, 3, the timing window, 4, the scribe lines, 5, the plunger follower, 6, the timing window plug. There are 2 indicating points mounted above the timing ring. 1 point indicates the right bank timing, the other indicates the left bank timing. The viewing of the timing ring, the free end of the engine. See figure 5.6. Note the right bank indicating pointer appears to be the left. Figure 5.6 pump set marks on the timing ring. You have your point for right cylinder bank, and then you have your timing ring, and then your point for left cylinder bank. The left-hand side of the left bank with the pointer side of the right-hand side. Note that you have care not to confuse the 1 through 8 top dead center mark on the 1 through 8 set mark. The caution: incorrect injector pump timing can cause excessive plunger travel, which may result in the damage to this pump. Note the tappet setting of the inlet exhaust valve for the cylinders can be checked. If necessary, readjust at the same time of the fuel pump on the cylinder is being timed. Number 1, right cylinder pump is used with example of a good starting point with the U of the all engine pump at the top center to be timed. Back off the compression release plugs on the full turn 1 on all cylinders. Remove the cylinder head cover the plugs from the fuel pump timing windows. 3, remove the coverage head over with a tappet rod adjusting nuts. See figure 5.4. Using the bar over the cover bearing over tool, slow the bar crank shaft over the direction rotation until timing mark 1.8 set exactly lines up with the right bank of the point. See figure 5.6. Check all the valves are closed over the 1 right cylinder and firing stroke with the valves closed and on a small amount with the free movement that denoted the manually moving the rocker arms. 6. If the valves are not closed, rotate the crankshaft 1 more revolution in the direction of the rotation. Stop on the 1 through 8 set mark. Will recheck the valves. 7. Adjust the fuel pump. Tap it now with the 1 right cylinder on the top edge for the plunger valve with exactly aligned with the scribe marks on the side of the fuel pump timing window. See figure 5.5. Lock up the tappet and unsecurely recheck the alignment of the pumping timing marks as correct. Proceed with the pump of the 1 left cylinder using the back pointer against the using 1 8 set mark for turning the crankshaft until the mark is exactly aligned on the left's back pointer. Proceed the next cylinder of the firing order. Repeat until the 16 cylinders have been timed. Make sure that each tappet nut is locked before leaving it. 10. After all the pumps have been timed, replace the tap of the rod, adjusting cover the cylinder head cover and the fuel pump timing window plugs. Remove the bearing over the tool. The fuel nozzle function. The nozzle is a device used to inject the meter to mount with the fuel of the cylinder clearance at the exact required instant during the compression stroke. The valve in the nozzle is sealed for the fuel passage into the nozzle tip that prevents leakage for the fuel during the rest of the cycle. Spray holes atomize the fuel in the very fine mist with a symmetrical pattern to make for the compressed air with the starting ignition maintain the combustion. Description. The fuel injection nozzle, see figure 5.7, located with the cylinder head injection fuel oil directly into the cylinder with the consists of the holder body with the fuel injection duct and drain duct, the valve body with the nozzle tip, the valve loading spring, stop plate for spring pressure, adjusting shim with an adjusted nut to hold the assembly together. The hydraulic pressure of the fuel is 3,500 to 3,800 psi in the chamber between the valves, even the valve that exceeds the valve spring pressure of the valve is forced open. When the valve is open, the fuel oil and the high pressure flow from the chamber between the valve seat bounded the nozzle tip with the spray with the cylinder head through the spray holes of the nozzle tip. As the holes are orange with a few thousand with an inch diameter, the oil sprayed from them forms a fine mist with the mixture of the compressed air with the cylinder to form the combustion mixture. But the mixture is ignited by the heat created with the compressing of the air trips in the cylinder. It burns rapidly and produces the increased pressure needed to drive the piston on the power stroke. A small quantity of the fuel leaks upward between the fuel valve stem and the valve bore of the lubricating with these parts. They then go through the drain from the nozzle holder between the body directly into the drain compartment under the cylinder head cover from the head of the drain from the tube of the fuel pump housing combined with the drain fuel from the fuel injection pump, eventually returning the fuel tank through the fuel return header. 5.7. Cutaway showing the fuel injection system cylinder. 1. Starts as a cylinder head cover. 2. The high pressure fuel line. 3. Fuel nozzle. 4. Injection pump. 5. Fuel inlet valve. 6. Fuel drainage passage pump enclosure casting. 7. Control rack. 8. Fuel drainage passage. 9. Injection pump pass push rod. 10. Cylinder. 11. Push rods adjusting lock nut. 12. Fuel drainage passage. 13. Fuel drainage header. Removal. The surface of the injection nozzle must be removed from the engine. Clean all the point pipe joints and cylinder heading. Use the fuel oil stiff bristle brush. Disconnect the high pressure fuel line. Remove the nozzle holder. Figure 5A shows the nozzle knocker tool, the sliding weight nozzle knocker bolt. If the nozzle holders are bound due to the carbon buildup, they remove the nozzle knocker tool shown in Figure 5A. After the nozzle holder is removed, remove the gasket in the bottom of the cylinder head recess. Insulation. Clean out all the carbon with the nozzle holder. Recess the pore of the cylinder head. Make sure the tip of the end of the nozzle holder is clean. 2. Place the new copper gasket on the small end of the nozzle. Small amount of the grease can be used to hold the gasket in place. Insert the small end of the nozzle holder into the recess pore. Orient the fuel drain plate with the clamp plate over the nozzle holder and follow holder studs. 4. Apply the self-locking nuts and them to the torque value listed in the data section. Caution. Proper tightening of the nozzle clamping bar nuts is important. If they are not tight enough, the exhaust gases will cause escape. The exhaust gases will cause carbon buildup between the fuel nozzle and the nozzle pore. Cover the nozzle holder bound with a plate for the clamping bar nut to tighten the accessibility parts for the nozzle valve with assembly. Will become distorted, causing the nozzle valve to leak with excessive tightening over these nuts with the cut, and also cover the cracks developed between the nozzles opening in the valve seating boards of the cylinder head. In the extreme case, if it can result with the unseating of the exhaust inlet valves. 5. Remove the protective cap at the end of the high pressure line with the bumps and the nozzle connections. Apply with the high pressure line with the tightening of the nuts. Be certain that no dirt gets into the connection. Check for the leaks of these points when the engine started. Storing spare nozzles. If the fuel nozzle assembly is not immediately installed on the engine, pour clean the SAE10 lubricating oil into the fuel inlet drain hole. Seal the openings using the cap plugs and commercial prepared the hot plastic dip, the ethanol cellulose. Protect the nozzle tip of the covering of the spray hole with the grease dip nozzle with a hot plastic dip of the ethanol cellulose to avoid damage. Handle the parts carefully and store them in the clean, dried area. Never take the chance with the injecting equipment if it needs to renew them rather than trying to extend the life. Data. Tank capacity. Large tank 3,000 gallons. Small tank 1,700 gallons. Fuel booster pump 1,800 RPMs. Pressure 40 psi. Fuel 3 gallons per minute. Valve setting. Pressure relief 75 psi. And pressure regulating 35 psi. Injector pump. Timing beginning of the injector 28 degrees, bottom top dead center. Torque values. Injector pump adapter sleeve 320 to 340 pounds a foot. Delivery valve holder 300 to 320 pounds a foot. Nozzle mounting nuts 30 to 35 pounds a foot. Nozzle assembly 130 to 150 pounds a foot. Injection pump and mounting bolts 45 to 50 pounds a foot. Alright, you have 1 is your cylinder drain, 2 the fuel heater, FU, 3 the fuel restraint, and 4 the fuel pressure gauge, 5 the fuel tank sight gauge, 6 fuel level gauge, 7 the tank fill with 8 the test points, 9 pressure regulating valve, 10 pressure relief valve, 11 booster pump, 12 condensation drain valve, 13 drain plug, 14 fuel tank, 15 fuel tank vent, 16 fuel header, 17 primary fuel filters, 18 secondary fuel filter. Alright, back into description. Cooling water system components. Locomotive, the cooling system, pressurized water system, which maintains essentially with the constant engine and operating temperature throughout the load range with a wide variation. Ambient temperature. The system also supplies heat to the cap heater, the water cooler, air compressor. See Figure 6.5. The cooling system consists of the following principal components: the water storage tank, the water pump, the water inlet headers, water discharge header, flow control valve, radiator section, cap heater, lube, oil cooler, and valves and interconnection pipes. System operation. The water storage tank located just to the forward out of the inside below, but the radiator panels contain with the supply of the working coolant in the system, 2 filling openings equipped with the spring-loaded caps. are located near the top of the water storage tank. The openings are situated to allow the water to add to the tank from either side of the locomotive. Note that some of the locomotive models may be equipped with only one water fill, and usually on the right side of the locomotive. When water leaving the storage tank of the drawn downward through the vertical tube, the lubricating oil cooler is conducted with the suction side of the engine drawn central figure water pump, simplifying the pipe system. The drains lubricating oil cooler was bolted directly to the storage tank lowest point with the cooler to support with the locomotive platform 3 adjusting the feet. Water discharge from the pump and enters the lateral patch of 3 end with the cover of the engine where the distributed inlet water head pipe for the turbocharger and intercoolers. The inlet water headers on one along each side of the engine to distribute the cooling water. But some of these headers are made of the above the A section with the indicator individually removed. Each section is bolted with the cylinder connected with the adjacent section of the joint pressing by the dressing couplings. The cylinders contain wet lines surrounded with the vertical passage cooling incoming water filtered downward through the passage, upward and out through the additional passage for the cylinder head. The engine intercoolers, which remove the heat from the combustion air, are constructed with a fabricated steel cave that enclose the fan with the tube type of the radiator cooler, cooling the water free end of the cover, and through the bottom of each of the intercooler passes with the vertical 3 times through the core of the discharge of the top of the cooler with the water flow with each of the intercooler is limited an orifice cooler discharge opening. Turbochargers are located with the free end of the engine with the receive the cooling water through the opening for the top surface of the end of the cover. The openings are aligned with the opening for the base for the turbocharger bracket. The mating connections are sealed with the O-rings. When the water discharge for the turbocharger for 3 openings near the top of the exhaust gas inlet side. These openings are in turn connected with the discharge pipe at the left intercooler. Water supply through the air compressor for the cab. The heater with the pipe connected with the inlet water header on the left side of the engine. The return of the system through the pipe, which extends along with the right side of the engine, that is connected to the bottom header for the loop oil cooler with the desired fuel heater, which is optional. Equipment that may connect to this line with the compressor supply with the pipe connected to the fuel control valve with the discharge for the radiator for return pipe. The discharge water header is centrally located lengthwise over the engine with the discharge opening connected to the junction box over the top of the right intercooler. The branch pipe welded with the header are connected with the individual cylinder with the dressing fitting of the water held along the intercoolers. Turbocharger discharge water header combined with the junction box connected to the flow control valve. The flow control valve is mounted with the forward left of the corner of the water storage tank to regulate the temperature of the system with the routing of the water flow for the engine and the flow of valves to the figure 6.5. Directly the water storage tank with the minimum engine cooling is required with the forward with the 2 radiator section when the partial cooling is required. 3 to all radiator section when the fuel engine cooling is required. When the water cooling is radiator, there is return with the storage tank of the minimum of the engine cooling. The flow of the water radiator is cut off with the flow control valve with the water left in the radiator section piping is quality drain with the storage tank of the gravity flow. Cooling water treatment. In order to maintain efficiency of the diesel engine cooling water system protected against corrosion, the erosion of various metals contained with the fluid, but the water should be kept clean with the proper link alkalinity and alkaline hardness inhibitor concentration. The may be accomplished by using sodium chromate water treatment compound concentration between 4,000 parts per million to 25,000 parts per million. 4,000 parts per million, 2,500 parts per million. Any dry treatment should be completely dissolved before adding with the cooling system. Solution should be prepared with the opening of the containers, adequate ventilation. Parts and decks should be washed and cleanly dried once on or spilled compound. Warning, chromate compounds are toxic. Suitable precautions must be taken with any of the person handling to avoid inhaling the fumes or dust to avoid skin contact with the solid or solution. The coolant should be checked with a sufficient frequency, particularly with the humid conditions reached for the save. Ensure the maintain with the recommended limit of checking the period that should not exceed 1 month. C.5. Limited presence of the non-furious component of the cooling system. If the coolant should become contaminated with sludge, dirt, and oil, if the contaminant should be found with the corrective of the system clean as described on the cooling system maintenance. Approximately 1 pound of the commercial chromate treatment, such as the Nalco 38 or Dearborn 517 equivalent, is required for each 20 gallons of raw water in order to allow the gradual dilution with the concentration rate of the water level. The expansion tank of the locomotive system, low idle to full idle, requires approximately 60 gallons of water. Water treatment testing kit is available with the GE catalog number 147X1225. Using this kit, simple 4-step procedure permitted to maintain the read for the table the number of the pounds for the chromate water treatment, which should be added to the locomotive cooling water system, restoring the 4,000 parts per million concentration. Filling locomotive cooling water system that can be filled through either two filling opening located near the top of the water storage tank. The opening situated to allow the water to ebb to either side of the locomotive. See Figure 6.5. Note some of the locomotive models may be equipped with only one water filler, usually located on the right side of the locomotive. Two water level side gauges are located on the water storage tank. They are marked with an indicating normal water level that curve through the various operating the condition of the cooling system. When the locomotive is operating, large fluctuations will occur with the level of the water with the side glass of the storage tank. This is normally called with the water varying amount is being diverted from the storage tank with the radiators during the interval cooling. When the filling of the system is completely drained with the condition of adjusting water proper level over the engine idling to allow trap of air to vent the system. Cooling water system. Note, water will be forced out over the fill pipes by the pressure of the system if the fill caps are removed when the water level is above the fill idle mark on the gauge. If the system is excessively hot before removing the cap to drain some of the water from the system for allowing the system to cool down. In either case, slowly turn the fill caps to allow the system pressure to be vented before removing the caps. Caution: do not operate the locomotive if the water supply drops below the level of the marked low idle with load or low load on the side glass. The engine may overheat, become the damage operated with water below the indicated level of the treated water with the proper level of the engine idling. Draining, Figure 6.5. The cooling system is equipped with three manually operated valve with the main system drain valve located near the base of lubricating oil cooler, two cab heater shutoff valves B, C, and B and C located near the operator's cab near the cab heater. Because of the pressurized system, drain time will be greatly reduced. The system is vented with the atmosphere by removing one of the filler caps. The system can be completely drained by opening the valves A, B, and C with the freezing weather. 1/4 inch drain plug must also be removed with the water pump with the impeller casing. Caution: to prevent cab heater from the core of the freezing during the extremely cold water heater with removed valves B and C must remain fully open at all times, and if the emergency the valves must be closed. The pipe connections to the heater core must be loosened to permit the core to drain. Flow control valve. The flow control valve that has no manually adjustment with the no manual adjustment. The valve is made with the aid of the thermostat with the two pistons, the type of the valve, the filter screen, and all housed fabricated steel case with the valve case with the mount over the opening of the water storage tank that is connected with the engine with a single pipe. The radiator section of the two pipes with three removable cover to permit the access of the control valve. The internal of the rectangular cover that is over the thermostatic unit with the two-cylinder and circular covers over the V1, V2 piston type. They're over the 1.5 inch pipe. The boss is provided with the outside of the case that permit the installation of the temperature test gauge. Valves within the case. Thermostatic valve. The thermostatic function of the two-way valves when the water temperature is below the operating portion of the point as soon as Figure 6.1 to A with the path of the water directly through their cylindrical bodies to water tank below. When the water is increased, the temperature sensitive to the compound with the bulb located at the top expands to overcome the spring pressure, forcing the skirt downward. See Figure 6.1b. With the skirt moved to the opening with the bottom, it becomes more and more restricted. The previously closed open. The top of the skirt increased the size of the permits water pressure to the start of the building of the adjacent chamber. Our Figure 6.1 shows the operating of the thermostat, and at closed position, the bulb, spring, seat, skirt, and the closed position. The Part B shows the skirt moves downward. Our piston type valve. The condition of the valve flow through the radiator of the control with the two snap action piston type valves V1 and V2. See Figure 6.2. Vertically mounted with the case of the valves either consider the upper lower portion of the connected by the seam of the valve is identically interchangeable with the center portion of each of the valve. How permit will leak for the past the upper portion that return through the valve of the storage tank, and then thus leakage has no effect on the operating of the system. The accurate operation of the weight of each of the valves is held with the closest limits during the manufacture. Successful operation system during the freezing of the weather depends on the water flow through the radiator sections being either at the high rate or complete off. The trickles of the water completely permitted to pass through the radiator ice would form into the tube. The snap action with the piston type of the valves accomplishes this purpose. Combined operation. The flow control valve regulates the temperature for the cooling system directly. Water flow through the following manner. When a minimum engine cooling is required, the water discharge from the engine enters the chamber that aids the flow of the downward through the filter screen. The thermostat, and if the thermostat is below operating temperature, water passes through their lower operating opening tanks. Tube water pump partial engine cooling is required. The engine discharge water temperature arrives with the thermostat being operating with the downward movement of the skirt partially restricted the water flow to the tank at the same time opening the top of the lower skirt, allowing the water to enter the chamber to B. The pressure node begins to develop in chamber B. When the thermostat has been removed, the skirt with enough to cover the pressure of the breach of the approximately 4 psi valve V1 snaps upward and limited for the travel to chamber B. Now in the chamber C, with the chamber C is closed with the storage tank at the lower position of valve 1. The water flow for the chamber C through the pipe connection radiator section 1 and 2. At the moment, the V1 water pressure for the chamber BC is somewhat below 4 psi. Valve V2 does not open. The V1 remains open. However, because of the air between the upper piston position of the exposure, the pressure is still large enough to hold V1 up, even if when reduced. If the cooling demands are not satisfied, but the water temperature remains approximately constant, no change of the valve position and take place a small variation of the cooling requirements satisfy the slightly opening of the closing of the thermostat of the modulate flow. If the cooling requirements should be fall off, the thermostat will close the opening of the top of the skirt with the end of the opening of the existing exit of the tank sufficient lower the pressure chamber to B and C with the position gravity pull valve with the V1 to be down to closed position, resulting in an again situation depicted in Figure 6.2. Air with the storage tank that enters C, the radiator drain permitting it to drain. 3. When full engine is cooling required, Figure 6.4 with the valve with 1, but the engine discharge with the water temperature continues to rise, but the thermostat will still further restrict the water flow with the storage tank at the same time to allow it to increase the flow of the chamber B, C, and C. Pressure in the chamber again with the increase with the pressure of the reach is approximately 4 psi for the second time. The valve 2 pressure 2. The valve 2 will snap upward and limit of the trap of the chamber C will now open the chamber D. The chamber D is closed with the storage tank of the lower piston. Valve 2, the water flow with the chamber D through the pipe connection of the radiator section 3, 4, 5, and 6. Water is now flowing with all the radiator section, resulting in the maximum cooling system of the SB before the small variation of the cooling requirements are satisfied and slight opening closing of the thermostat modulate flow. When the engine cooling requirements decrease, when the cooling requirements decrease, sufficiently sequence operation previously described will be the reverse thermostat will gradually reduce the water flow, thus reduce the pressure of the chamber B, C, and D. Because of the higher rate of flow, the greater decrease of the pressure for the curve of the chamber D, causing the V2 valve the first to open the valve T2. The closes for the flow of the water radiator section 3, 4, 5, and 6 will be shut off. At the same time, the radiator section will be vented with the storage tank of the lower piston on the valve 2. Thus permitting the water of the remaining of the section quickly drain the tank. Water pressure in chamber B and C will increase somewhat with the closing of the V2 and valve 1 will remain open. If the cooling requirements consider the decrease, members have further reduced the pressure for the chamber B and C with the pressure of the chamber C will become sufficiently low. Valve 1 will close, shutting off the flow of the water radiator section 1 and 2. The valve 2 radiator section are vented to the storage tank through the low position of valve 1, thus permitting the water to remain in the section quickly drain the tank. Inspection and repairs. It's not necessary to drain the water system. They inspect to replace the parts of flow of the control valve. Since the water is only present with the valve during the engine, the operating proceed with the C as valves in C Figure 6.1. Remove all the coverage over the thermostat, the valve 1 and valve 2 of the valve. Check the position type of the valve 3 free vertical movement, lifting them and releasing them. If the movement is not free, check the valve position surface of the cylinder wall, scoring the foreign material of the polish, the scored surface of the 320 grade over the emery cloth. Remove the decreased dresser coupling with the discharge water line with the engine flow control valve. 4. Remove the collar and a short length with the pipe of the flow control valve to allow the removal of the filter screen. 5. Pull out the cleaning of the flow control valve filter properly seated. 7. Remove the thermostat test for the proper operation of the agitated hot water. See the data for the proper temperature value to renew any of the defective units. 8. Reassemble the parts and inspect the cover gasket and the collar O-ring. Renew the gasket and the O-ring if damaged or replace some covers. Our safety devices, engine high temperature switch. The engine high temperature switch is mounted on the flow control valve with thermal electrical safety device. The function of the alert the operator should engine the temperature become excess for the temperature of the water discharge of the engine reach for the temperature setting with the switch with electrical contacts with close the energized light with the bell with the operator of the cab. To ensure the proper operation of the switch should be inspected with the test of the hot pot which the switch in place and remove the cover plate with the check to make certain that the electrical connections are secure. Here the contact with the good connection. The contacts are burned and pitted. May be dressed with a circuit energized with using a small and fine flat file. Do not set this caution. Do not set the switch on the locomotive with the covering the radiator inlet screen with the can damage to the engine with the air filter system. See the data switching settings. Caution: when conducting the test, do not allow the temperature of the cooling water discharge from the engine to exceed 205 degrees Fahrenheit. So the switch required adjustment closing the opening setting that can be raised lowered simultaneously by turning the external adjusting screw with the switch gate. The differential setting of the switch can be adjusted by changing the magnetic air gap of the movable contact. However, the adjusting is quite difficult to make it and should not be tampered with when adjusting the switch of the locomotive. When checking the engine high temperature switch, the immerse of the switch tube with the potted aggregated water. Slowly raise the water temperature until the switch contacts close. Lower the water temperature until the contacts open. And if necessary, reset the switch. Same proper opening and closing valve. See data. Alright, low water pressure shutdown. Low water pressure shutdown is automatically safe device for the shutdown engine with a vent with a cooling water failure. The device is mounted on the left side of the engine. Control govern the pipe of the engine inlet with water. Head of the pressure for the cooling water pipe supplied with the engine cylinder drops below the required safety operation for the engine. Water pressure for the device for the function shutdown of the engine. Operating device adjustment. Details engine control governor and governor instructions. Radiator, see figure 6.5. The radiator is made up of the 6 individual sections, 3 on each side of the locomotive, mounted on the slope of the downward locomotive center line. With the outer side of the screen is mounted over the upper side of the radiators to protect them from damage. Radiator section is alternately numbered starting with the water storage tank. The odd numbers are on the right side of the locomotive. The even numbers are on the left side. Pipe connecting chamber C with the flow control valve inlet radiator section of 1 and 2 with another connection with the chamber D with the flow control valve with the inlets radiator section 3, 4, 5, and 6. Pipe connections of the radiator sections are made with the dress ring fittings to permit easily removal. Cool water flow for the radiator section through their respective drain header of the pipe of the water storage tank. The small pipe connected with the parallel to the large drain header with the sure of the complete draining of the locomotive on level track. Data: tank capacity, water capacity 290 gallons. Valve setting, flow control valve thermometer starting opening at 165 degrees, full opening at 180 degrees Fahrenheit. Valve skirting travel with the closed to fully open minimum 11/32 of an inch. Any engine temperature switch. Contact closed 205 degrees plus or minus 2 degrees. Contact opening 193 degrees Fahrenheit plus or minus 2 degrees. Torque values: water pump driven drive gear nut at 200 to 225 pounds a foot. All right, we're starting from the top. The thermostatic show this is figure 6.2 flow control valve operating condition minimum engine cooling required. Temperature overrated thermostatic filter inlet screen valve 1 valve 2 chambers C C D D and the A and B on the left side. Flow with the water through the storage tank and the temperature test gauge fitting. Figure 6.3 flow control valve operating condition partial internal cooling temperature operating thermostat valve A the flowing of the water through the flow of the engine through the B and the filter screen the valve 1 valve 2 chamber C and D temperature test gauge outlet to radiator section 1 and 2 outlet to radiator section 3, 4, 5, and 6. Alright, 6.4 flow control valve operating condition full engine coolant required. Thermostatic operated thermostat valves A flow of the engine through the A and B and to the B through C to operated outlet radiator section 1 and 2 the valve 1 into valve 2 outlet radiators 3, 4, 5, and 6 in chamber D. Alright, cab heater, cab wall, cab heater, air compressor, engine compartment, governor, low water shutdown device, inlet water heater, fuel heater connection, if used, rudder, inlet connection, pump, drain, punch, system fuel openings each side of the tank, and water treatment here, and the test engine discharge water temperature, engine high temperature switch, discharge water header, turbocharger, left inlet cooler, test engine inlet water temperature, pressure, flow control valve, water level, sight gauge, each side of the tank, water storage tank, loop oil cooler, radiator adjustment. Note, the in freezing weather, ensure the against the freezing with the cab heater radiator valves B and C must remain fully open at all times. Complete drain system open drain valves A, B, and C. Remove the pump drains plug. Alright, section 7.